All right, we're going to be looking at college versus pro football attendance today and to see if there is evidence that more people attend college games than NFL games. Let's take a look at the information we have here. We'll start out with the NFL. They give us a sample size of 35, so n equals 35. We have a mean of 68,729. Standard deviation of 6,110. Now for college, let's see what they give us here. Okay, we have a smaller sample size here. We have 30. We have our mean equaling 70,358. And we have a standard deviation here, a little bit bigger, of 9,139. All right, so we're going to be running a test here. Now, bear in mind, they're asking us here, is there evidence that attendance is greater at the Big Ten games? We're not just trying to see if our attendances are different. We're trying to see if one is greater than the other. So let's see. Let's start with our null hypothesis. Now remember, our null is always going to be some sort of equal statement. So you have two options here. Here's the way I'm going to present it. I'm going to go with mu of, let's say, C for college equals mu of NFL. So the mean of college is equal to that of the NFL. That's going to be our null hypothesis. You always want it to be an equal statement. If you want to go another route, you can also go with this. Mu of C minus mu of NFL equals 0, because if there was no difference, then you should be getting an answer of 0. So you could go with either of those for your null here. Now for our alternate, let's try that out. Trying to prove that Big Ten is bigger, so we're going to go with mu of C is greater than mu of NFL. So that's going to be our alternate here. We're going to be trying to prove that one is greater than the other. If this were a two-sided test, it would be that they just aren't equal. All right, so let's see. Now for our, well, if we want to write it a second way, we can still go with mu of C minus mu of NFL. Now, if college were greater than the NFL and you were subtracting those two values, you'd expect your answer to be greater than 0. So that could be our other alternate here. So you have two choices here. You could go with this option or this option. You don't have to use both, but you have to pick one or the other. All right, so next, we should run our test? No, we shouldn't. We have to do our conditions first. You got to do your conditions. Let's check these conditions. All right, so let's see. Random. Is it random? Let's see. Random sample of NFL games. Love it. Check. How about for Big Ten? Was that random too? Random sample of 30 big conference games. Good. Random is checked. We're in good shape here. Now, our next condition. N is greater than or equal to 30 or comes from a normal population. Let's take a look at our sample sizes. We've got for college, 30 is greater than or equal to 30. That checks for our college or our Big Ten. For the NFL, 35 is greater than or equal to 30. Certainly is. Excellent. We've checked that condition off too. Luckily, we didn't have to do a histogram or a dot plot here. If these were less than 30, we would have had to prove it using a histogram or dot plot to say it looks kind of normal, but we don't have to do that here. All right, now our last condition is, let's see, 10%. All right, referring to a specific season. Nope, I'm not even referring to a specific season. So let's see here. We've got 30 college games. Is that less than 1/10 of Big Ten games? I think that's safe to say. Because again, they're not just talking about one season, they're talking stretched out. So I think it's very safe to say that. For the NFL, 35. It's 35 games, less than 10% of NFL games. Definitely. I mean, you could even look at one season for that and be pretty confident. Let's go back here. Are they comparing over one season? No, there isn't. So we don't even have to assume that's based on one season. We're just talking in general. So we are good. We've got our conditions checked. And remember, notice I did it for both college and NFL. You have to do it for both. All right, now our next and our last step here, we're going to be running our calculator function. Whoops, didn't want to do that. Let's try that again. Pull that up. Cool, so we're going to do second quit. I'm going to go to stat. I'm going to go to tests. I'm going to go down to, this is a 2-sample t-test. This is based on 2 samples. All right, so let's take a look at 1. I established 1 here as college, so I'm going to enter in my college statistics. So I had an average of 70,358. Let's see. Oh, I want to clear that because I'm not using data. I'm using stats. There we go. That's what I want to do. That other option, that's if you want to enter in all the information. Then the calculator finds all the averages for you. It's kind of cool, but you don't have to do that here. And I'm having some issues. Let's go back here. Quit. All right, try again. All right, so let's... Oh, here we go. Maybe that'll work. All right, good. Now we're in business. Yeah, I know you guys are working with TIs most likely. I'm using something that's close to it, so hopefully the functions are very similar here. All right, so notice I entered in college first. Second, I'm going to enter in the NFL. So 68,729. Standard deviation of 6,110. Sample size of 35. All right, now here's where the tricky part comes in. What do I enter here? Now my first average is going to be college. So what am I trying to prove? The first blue one here doesn't equal. That'd be if I was just trying to prove they're different. I'm not. The second one here, I'd be trying to prove that college, mu1, is less than mu2. I'm not trying to prove that college is less than the NFL. I'm trying to prove that college is greater. So I'm going to go with my third option here. This can be a tricky part here. So you really want to kind of think about what is mu1, what is mu2. All right, and then I just hit enter. And let's try that again. Go down. I can draw it. And no, notice how it says pulled, yes or no. You don't want to pull your data here. See what happens if I draw it. Mine doesn't work well when I do that. Maybe yours works better than mine. All right, so I'm going to go here. Oh, it looks like I got my calculations. Awesome. So I'm going to write these out. Let's see. I've got my T. That's important. You always want to write out your test statistic. So it looks like we're only about 0.83 standard deviations away, not even a whole standard deviation. And you're going to notice our p-value is going to be 0.205. It's non-scientific notation either. Take note of that. Common mistake is a lot of people will see a number, it'll look like a whole number, and they'll forget that it's given to them in scientific notation. So just be careful of that. Let's see, can I get rid of that? Oh, still having issues getting rid of that calculator. I'll keep it off this side anyway. All right, so now that I have my p-value and then my test statistic, I can come to a conclusion. Remember, we're usually using a 0.05 for a significance level unless that is emphasized. Sometimes it might be smaller, sometimes it might be greater. All right, so let's take a look. Our p-value looks like it's greater than our significance level. 0.05 is greater than our significance level. If we're getting a p-value greater, we don't have enough evidence here. We expect to see the statistic about 20% of the time if it really is equal. If it really is equal, if the college attendances are really equal to the NFL, probability of getting the statistic we should get it about 20% of the time. Not super likely, but likely enough that we can't say that college has a greater attendance here. So what am I going to do? Since my p-value is greater than my significance level, I fail to reject my null. So what does that tell me? That means I haven't proven my alternate hypothesis here. My alternate was that college was greater, so I don't have enough evidence to prove that. I do not have enough evidence to prove Big Ten attendance. So Big Ten has greater average attendance than the NFL. Take note that I am not accepting my null hypothesis. You never accept the null. You can fail to reject it, which is what happened here. I failed to reject it, and I do not have enough evidence to prove my alternate. So hopefully this helps you out when it comes to this problem. You'll be seeing some more like this in the future. So if you have questions, you can reach out to me at my school email address, or if you're not a student of mine, you